Hello. Hello, good afternoon, everybody. I see we have people connecting, so let's wait a little bit more. Hello, good afternoon, everybody. Cristina Lumbreras from EENA speaking. We have today the first of two webinars about the Next Generation 112 project that was organized by EENA. We launched the project in the last EENA conference, and we have worked during all this year on the Next Generation 112 implementation with three consortia. We will have today the presentation of the first consortium called CELESTE. We will have three presenters with us. I will introduce them to you in a few seconds. First of all, I also wanted to share with you some practical aspects of running the webinar. All the material, the recording will be available after the webinar, and we will have a session of Q&A after the presentation, and you will have the opportunity to raise your hand in case you would like to speak. So I will unmute your microphones if you want to share some ideas or make some question orally. In any case, you can also use the chat or the questions in written questions in the chat, in case you prefer to ask the questions in write the questions. Okay, so I think now we have already give some extra minutes for people to join the webinar, and I think we can start now. So as said, this is the first webinar. We will have two. Today is the CELESTE consortium, and on the 8th of June at 2 p.m. Brussels time, we will have the presentation of the two other consortia that participated in this project, that there will be the Turkish consortium and the Croatian consortium. And I think it's time now that I give the floor to our three speakers today. It's Michael Pröstler, Luca Bergonzi, and Wolfgang Kampichler, who will share with us what they have done during this year in the NG112 project. So Michael, the floor is yours.
Okay, perfect. Okay, thank you, Christina, for the kind introduction. I would like to also welcome you all today for this webinar. My name is Michael Pröstler, and I'm the founder and CEO of GridGears. And together with my colleagues, Luca Bergonzi from Beta-AT and Wolfgang Kampichler from Frequentis, we will walk you through our project and explain the results we have achieved. Just a short points in terms of the agenda. So I will start with a short introduction of our consortium and a rough overview of our project. Luca will then explain our achievements from a more operational point of view, and Wolfgang will provide then a deep dive into the details of our technical solution. So as cross-border kind of already indicates, there were several organizations, ministries, and companies involved in realizing this project. So we had the NG112 components, which were provided by Beta-AT, GridGears, and Frequentis. We had 4 different PSAP PSAPs on board in 3 different countries. So we had the Copenhagen Greater Fire Department in Denmark, we had the PSAP, the Leitstelle Tirol in Austria, and we had 2 PSAPs from Italy, namely Trento and Bolzano. In addition to that, we had great support and observers, and for example, the RTR, the Austrian Regulatory Authority for Broadcasting and Telecommunications, those provided us with hosting capabilities for the NG112 components. And in addition, we had the Ministry Interior of Austria, which provided us support on a more organizational level so that we could get access to the PSAPs, we're able to actually testing with the PSAPs, etc. So CELESTE stands for Cross-Border ESINet and Lost Hierarchy Emergency Service Testing. So in this abbreviation, there are basically 2 terms we would like to explain before we continue. So the first one is what is an ESINet? And the second one would be what is a lost hierarchy when we speak of it. So basically an ESINet is an IP-based network which provides or hosts the NG112 core services. And what is important is that basically the ESINet does not specify who is able to connect to the ESINet. Basically, it can be any trusted source. For example, usually it might be mobile network providers. But when you think of, let's say, voice over IP applications like Skype, or basically any VoIP trunk providers, they could also connect to the ESINet and forward emergency calls. In addition, what is also kind of raising now in the industry, IoT becomes a more important role nowadays. So think about, for example, that sensors, alarms, all of those types, sensors on drones could be connected to the ESINet and profit from the same powerful routing capabilities and features of the NG112 architecture. The second term, the LOST. So LOST stands for Location to Service Translation. And what that basically means is that it specifies an interface which allows us to retrieve information of which services are available and responsible at a specific location. So this is important because it's the foundation for location-based routing within one ESINet, but also in a different form, in the form of the forest guide, responsible for routing across multiple ESINets. Why do we need routing across multiple ESINets? So when you see our pilot setup, we had 3 different independent ESINets deployed in Austria, Denmark, and Italy. Each of them hosted the core components from our different providers. So we were able to try out different combinations and different deployment scenarios. And what was important is that each of those ESINets operated completely independently, but they were able to interchange emergency calls via a forest guide. Needless to say, all of the components followed the ETSI standard and the specified interfaces. So basically now I would like to give the floor to Luca Bergonzi, who will explain more about the operational impact of our pilot. Luca.
Thank you, Michael. So let's say, as you understand from Michael's explanation, Next Generation 112 contains a lot of topics. No? It's about changing completely the way we perceive today the emergency management in terms of communications. We are not even talking about emergency calls anymore. This will be emergency communications. And there will be a big impact also on the decision-making process of PSAPs, because there will be, if you want, more freedom to decide how to define the most appropriate PSAP for responding to emergency requests. We decided anyway to focus on 2 particular challenges that we see today for emergency service professionals, and show the way NG112 can solve these challenges. Can you go on, Michael, please? Michael? Thank you. So these are the two big topics we decided to focus on. The first was the location-based routing. As you probably know, even today, there are some issues when determining the most appropriate PSAP for serving a particular emergency call today. Sometimes these problems are due to network-based location, which is not 100% correct, or in principle, the idea is that you have sometimes bordering situations which are hardly defined by networks, and they cause misinterpretation of position, making the call go to the wrong PSAP. No? In the picture you see, we have the region of Trento, divided in two provinces. The red one is Trento, and the blue one is Bolzano. This is the region bordering with Austria. Normally you would say, okay, all the calls in the blue region on the top should go to the blue PSAP. All the calls in the southern part should go on the red PSAP. No, that's absolutely normal. But there are areas of misinterpretation. We decided to show how this problem is solved with the NG112 architecture. There is also another big issue, the cross-border relation between the northern part, Bolzano, and Austria. Because close to the borders, you have situations where calls from an Austrian phone coming to Italy actually are still routed to Austria, even on Italian territory, and vice versa. An Italian phone going to Austria can be routed to the blue PSAP instead of going to the right one in Austria. So we decided to talk about location-based routing and how this can solve, and NG112 can solve the problem for the next generation emergency communications. The second topic was the application-based routing. So in Austria, there is already an application called the DEC existing and implemented since last year, which makes use of a WebRTC client, which makes use of an SMS kind of system. It's a messaging system based on SIP, and it's dedicated, as you can see from the sign, to the deaf population. On this side, in Italy, we are testing a WebRTC-based application for next generation communication. We wanted to show how the NG112 architecture, Esinet, can actually route even determining the originating application. So the Esinet can understand, can sense whether you're using the DEC application from Austria or the WebRTC client from Italy, and according to the technology used, take different decisions. If you can go on, Michael, please. So these are the cases that I mentioned before, right? We wanted to show how today, on the left, some areas in the province of Bolzano actually are misrouted to the province of Trento. So the blue call, the blue icon represents a call which is sent over to the PSAP in Trento. The green ball represents a call from a, let's say, an Italian user which just crossed the border to Austria, but is referred when making an emergency call again to the PSAP in his originating province. Through the NG112 technology, emergency communications will be granted to be routed to the proper position. So the blue ball, the blue call, will go to the right PSAP in his own province, and the green call, which is placed in Austria, doesn't matter from which nationality, will be directed to the proper Austrian PSAP, even as you cross the border between the two countries. We focused on this kind of tests, and you will see the results later. And finally, when talking about these applications, so the next slide, please, Michael. The final discussion about this topic of deaf people and so on, we wanted to focus on the expansion of the communication methods for all the types of citizens. We are talking about sometimes SMS as a workaround to let the deaf community communicate with 112, 911, and so on. But we still know that there are problems around the SMS usage. Basically, SMS cannot be routed today. We all know about the ongoing technology considerations made in the US with the text to 911 situation, but this is not the only case. I mean, this is the one that has been given a name even, not text to 911. But in Europe, every country faces similar problems. We want to show how a SIP-based communication, including chatting, so including the evolution of SMS, will be perfectly routed to the proper destination according to the location, therefore overcoming the current issues we have with SMS. Not only this, but you will also see that NG112 technology allows other forms of native multimedia contents to be shared with the PSAP. Therefore, video calls, voice, of course, and messages as well. So these are the topics we addressed. And now I will give the floor to Wolfgang that will explain the architecture and the technologies that we implemented for the pilot.
Yeah, many thanks to Luca and Michael for the kind introduction. And as Luca mentioned, I'm going to talk a little bit about technical stuff. So just let me share my full screen that you can see the nice drawings we have. So I will start with the services that we were deploying. So basically, we, as Luca mentioned, we were focusing on two applications, one for chatting and the other one for multimedia communications. And we also decided in the team that we roll out different building blocks, that we have something that is more or less for the public side, then the Esinet and the PSAP components. So, but first of all, let's start with the applications. So we had this lightweight chat applications called DEC112. As mentioned by Luca, this is in operation in Austria since February 2019. So it's basically based on the SIP Simple RFC implementation, and it has also kind of session mode extension because SIP Simple is just message by message oriented implementation. And it provides location to the PSAP using the specifications we have in ETSI TS 103479, so basically the NG112 architecture spec. And on the other hand, we had the VoIP client or application that is based on WebRTC for audio, video, text, and also location. So basically both are quite close to the NG specification. So because we get the SIP session set up or the SIP messaging, we can use service URNs, and both applications provide the present information data format location object. So that's actually the content that provides the location, which is further on used for routing purposes. And at the end, at the receiving end in the PSAP, it is displayed. So you can see here on the screen an example of this application we have in Austria, so with the typical Austrian emergency numbers and some chat example. On the right side, you see the user interface for the PSAP. So you have the map with the actual location, also means for chatting. So that's actually the applications that we were using. And as mentioned before, we had 3 different deployments. And each of the deployments had these applications in use. So the deployment in Denmark and in Austria and in Italy was quite similar in terms of end devices for the public side. For the deployment itself, it's a bit different, but I'll tell you later. So moving on with the building blocks, since we have some international deployments, we had to decide how do we do the regional setup and how do we extend the regional setup to get kind of international deployment. So most important things here are the peering aspects. So which of the core services or the entities are talking to each other, and what configuration do we need, and what elements in a lost hierarchy do we need for that international deployment. In this drawing, you also see the border control function as core security element in an Esinet, but due to the lack of a partner providing a border control function, we decided not to include the border control function in our setup. So basically, we had kind of trusted service provider on the public side with the application backend and the SIP proxy for both applications that directly connected to an originating ESRP. But basically, if we would have had one, it would not be that difficult to put the border control function in between. So starting with the application part or the public part, we have elements deployed in each country that support, for instance, the DEC112 application, or also host bits and pieces of the WebRTC client. So each country has actually its own deployment. So there's no, let's say, central service provided for the backend. So they are really deployed in the countries. So in addition to that, as we're using the session initiation protocol, we had this SIP proxy entity, which is also part of this public deployment, and typically the application, being it DEC112 or a WebRTC application, registers with its local or home SIP proxy, and the SIP proxy itself appears with its local originating ESRPs, which would be the next element in the Esinet. So typically the initial steps for the registration are that the user logs on or downloads the app in case of DEC112 from the stores, provides some user data on a voluntary basis, and gets the SIP configuration from the backend. So the user doesn't need to understand all the SIP technology. He or she just types in the phone number, gets a verification code, and then is registered in an app backend database and can use the application. So we turned it actually off, this verification for the project, because we had well-known testers, so we didn't have to do this verification. But I think that's a very important thing if you run this service operational. The next element is the box representing the core services, or let's call it the Esinet. So here we have the emergency service routing proxy. So that's the element that understands the protocols and forwards requests from the public to the PSAP, and also interfaces to the emergency call routing function, which is called the ECRF. So in our setup, we had ECRFs for each region, so Denmark, Austria, and Italy, and those ECRFs are providing authoritative mappings for the region itself. So they didn't know about other countries or remote countries, they just provided their local mappings to their pairing ESRP. So there's always in combination the originating ESRP of an Esinet with an ECRF. In terms of peering with the public side, we had a setup where the SIP proxy, the one in the red box from the application, forwards emergency calls. So we had a trunk configuration setup there, TCP or DLS, between the SIP proxy and the originating ESRP. So that's the first step in the routing. So the SIP proxy decides, okay, the person called an emergency number, I have to forward it to the originating ESRP. This is because users may use the service for just calling other bodies within that service domain from one application to the other application. So that would also be handled by this DC proxy. And if it's an emergency call, then it would be forwarded to the originating ESRP. The originating ESRP itself, we'll see that in the next slide, peers with different terminating ESRPs. So that could be a regional and a remote one. The reason for that is if you look at the international setup, we need to also forward calls from one ESINet to the other ESINet, and for that purpose we decided to separate it into an originating ESRP and in a terminating ESRP. Last but not least, the ESRF makes up a lost hierarchy together with remote ECRFs and the forest guard. Yeah, coming to the blue box at the right end, we have the PSAP implementation. So for that, we're also using an terminating ESRP, and that one manages different kind of PSAPs. And as Luca mentioned, what was quite interesting for us to see if it's possible to utilize policy routing functions in order to route calls based on the content. And in our case, we had two applications for text chatting. Yeah, so there's the WebRTC based with total conversation has a text service in it, and the DEC112 has a text chat service in it. So it was necessary to utilize some policy routing function at the terminating ESRP to decide to forward specific requests to the right application. So in addition, in the PSAP, we deployed a kind of gateway for DEC112, which, depending on the capabilities of a PSAP, either triggers the CAT system, or the PSAP just opens a browser window to get the chat functionality and to see the map. And we also had the WebRTC clients on site for the testing purposes. I already mentioned the terminating ESRP, but just to sum it up, in our case, the clients within the PSAP, either WebRTC client or DEC112 gateway, register with the terminating ESRP, so that the terminating ESRP knows how to forward calls. So that's somehow similar to kind of TQ registration, but utilizing different kinds of mechanisms for the registration. Okay, next slide is then how does this regional and international routing work? So basically that's the most interesting part. For the regional routing, that's quite clear how this is maintained and deployed. So typical configuration is a zip proxy that maintains a trunk to an originating ESRP. So this is kind of a pre-configuration, the zip proxy, and I mentioned before that this is kind of trusted service provider. So the ESINet says, okay, there is a kind of web service provider or chat service provider out there in the internet, and I trust them, and I'm peering with that provider. In addition to that, we have the ECRF that provides the regional authoritative mapping, as mentioned before. So actually we are set up to forward calls. So if you start an application, typically it will register with the zip proxy. In the case of DEC112, it's you start up the app and you press a button, it will register with the zip proxy, and then it sends the first message. And on the other hand, we also have the PSAP CPE or the gateway or the WebRTC client that has already registered with the terminating ESRP. So that happens actually before any of the calls. Next step shows the message flow. So let's start with a user initiating a DEC112 chat as an example, which includes location, also a vCard with additional information, and the first text that's actually sent automatically, providing the name of the person in need and also the location. So that's the arrow 1 in the drawing, and since it is addressed to an emergency number, or a specific service URL, the SIP proxy knows, okay, this needs to be forwarded to the originating ESRP, which is error 2 in the drawing. The next step, so the originating ESRP utilizes the lost protocol, so it's a location to service translation, as Michael mentioned at the beginning, a find service request that's being issued by the ESRP, so RO3, and the ECRF responds back with the mapping, which in our case is a SIP URI that is pointing to the terminating ESRP. So originating then simply forwards based on typical SIP mechanisms to the terminating ESRP. And finally, the PSAP receives from the terminating ESRP the chat message, which is then being displayed on the user interface and also shows the location. So in order to open a kind of conversation, chat conversation, the PSAP sends back a response and providing some contact information utilizing the reply to header. So this typically would provide a SIP URI that points to a PCF, just referring back to the PCF situation, in order to let the application on the public side know how to connect to the PSAP. So that information flow runs back. So it's messages 7, 8, and 9. And after the app has received the information from its proxy, the chat continues, and it's always going back and forth. So typically the application uses its own SIP proxies, outbound proxies that's always routed via that entity. And this also keeps the trusted relation between the SIP proxy and the Esinet, or if there is a PCF in between, it would be from the SIP proxy to the PCF. So now we have this kind of conversation, and either end may terminate. So that's actually what we tested in the field, so just moving across the border, for instance, at Brenner, and in different countries where we had the deployments. The same is true for a voice over IP or WebRTC based application. The only big difference here is the different method that the SIP protocol provides in order to set up a multimedia session. So it's not the message method, it's the SIP invite to open a kind of SIP session, but in terms of routing, it's still the same. And with that VoIP or multimedia WebRTC based application, we had the capability to open a media session that includes audio, video, and text. And as mentioned before, it starts with some interaction from the user. Location will be provided with the call setup. It receives the originating ESRP, which then queries the ECRF and forwards to the terminating ESRP. And the PSAP answers the call. And as mentioned before, the terminating ESRP may decide based on a specific content of the message to which application it has to forward the call. So that was also in place. So the terminating ESRP was not just managing the PSAPs, it also utilized the policy routing function in order to decide to which application the request has to be routed. And now moving on with the international part. So basically the setup, the public setup is always the same. But now we have another new element, which is called Forest Guide. It's to the bottom of the drawing, it's called FG Forest Guide. And that knows about the regional ECRFs, so and their mappings. So we had this deployed for different countries. So the Forest Guide was aware of how to forward or redirect to an ECRF if the location is, for instance, in Italy, but the originating application is in Austria. But I will show this anyway later on in an example. So back to the scenario, we have a user from region A, for instance, moving to region B. So that means in region A, we have the application backend and the SIP proxy and the ECRF. And the application always connects to its application backend, or if it's the signaling part, then it would just connect to its local or home SIP proxy. Since we get the location information with the core setup, the originating ESRP, which is then step 2, would query its local ECRF because it is not aware of any other ECRF. And in our setup, we did it in a way that the ECRF just requests some information from the forest guide and gets a redirect from the forest guide, and thus on behalf of the requesting ECRF resolve to the authoritative mapping which is provided by the remote ECRF. But just go through it in steps. So first we get to the originating ESRP that has the location information and the service URL, and it sends a request to the ECRF, the local one. So there's no big change to the regional deployments or scenarios, and it does not find a mapping for that location because the location is in the other region. It's region B. What it does, it just asks the forest guide, please tell me who is responsible for that region, and the forest guide just responds back with a redirect information saying, okay, that's the ECRF in region B. And then the ECRF queries the other one, asking for the authoritative mapping, which is returned back. And then, the originating ESRP would know, okay, since this is in a different region, I have to forward it to the region B terminating ESRP, which finally forwards it to the PSAP. So there are a few more steps compared to the regional setup, but in principle, it's the same things that need to be done. And basically, for the application, it's totally transparent. So the application just forwards everything to the SIP proxy. The SIP proxy or the trusted provider forwards everything to the local originating ESRP, and then the magic happens in the back. The same works with the voice over IP part. So I think I don't have to explain it again. The only difference here is that we set up audio, video, and texting in a multimedia session, and we utilize different SIP methods, like the invite in this case, in order to set up a call. But in terms of the steps for the routing in the Esinet, it's comparable to what I've explained before. Yeah, finally, a few words about the deployment. So we had a deployment in Austria and in Denmark and in Italy. And the aim was to get different deployments in terms of hosting capabilities and also in terms of mixing different solutions from different vendors. So you see at least two different deployments. So here the Austrian and the Danish setup was quite similar in terms of services that were used in the scenarios, but we had different hosting partners. In Austria, our hosting partner was the Austrian Regulatory Authority, RTR, hosting the tech backend services and the SIP proxy explained before, so the public box. They also hosted the Esinet box with the originating ESRP, and we had grid gears providing the ECRF, so that was hosted somewhere else. So that is already kind of mix and match in terms of hosting. And finally, the PSAP side was also hosted by the Austrian Regulatory. And in Denmark, it was hosted by the Copenhagen Fire Department itself. So their IT department, they have quite good hosting capabilities, and then they deployed the services on their own. So we had different teams and different setups in terms of hosting, which was quite interesting to see how things are being deployed on different platforms or different hosting solutions. So that's basically the Austrian setup and the Danish setup, and there are some cross connects between the originating ESRP and the terminating ESRP, and also between the ECRFs. Now it's getting a bit more complex. So that's the Italian setup, and for the Italian setup, we had the Esinet deployed by Beta 80. So the complete elements, the core services like ESRP and ECRF. So only the forest guide was from GitGears, and Frequentis was hosting the application services and the DEC border gateway services just to support the PSAPs to connect via a simple web browser. But what you can see here, don't have to look at the tiny details, but the boxes and the different colors. So in the end system, we have the kind of orange box, which is the VoIP client or the WebRTC client, and then this blue box, which illustrates the DEC112 application. And for that purpose, we had a specific routing, kind of policy routing. Here is just a simple example how that works or could work in the terminating ESRP. So basically, the idea was to find out, okay, is it a call coming from a DEC112 application getting through to the terminating ESRP, and the terminating ESRP would then decide, okay, this is DEC112. I would have to forward it to the DEC112 infrastructure that is local, or if it's a WebRTC based, I would have to detect this and forward it to the WebRTC endpoint. So that was quite challenging in terms of configuration, but really interesting to see how policy routing could work if you would like to route to specific applications, or let's say to specific PSAPs with specific capabilities.
If I may add, Wolfgang, before you continue,
yes,
a couple of interesting, let's say, information on this setup. The first is what Wolfgang just mentioned, the difference in colors between orange and blue is a very explicit representation of interoperability. We didn't mention this topic in the beginning of the purposes of this pilot because we take for granted somehow that systems like these interoperate with each other. That was tested already last year and the year before during the plug test event organized in ETSI, but this is an important topic. What you see here in this picture is two infrastructures developed and deployed by different companies, interoperating between themselves just by the means of configuration. No extra development, no custom things, nothing. These excuses are, so to speak, gone with the next generation technology. The second important thing is that orange parts were developed and deployed by Beta 80, but who was hosting them? Well, nobody. In other words, we decided to put the installation on the cloud, also to give an extra value to the installation. It means that these components are already designed and created to be operating in any kind of environment, whether it's hosted by, let's say, a PSAP, a private company like a carrier, or even on cloud services. Okay, floor is yours.
Yeah, thanks, Luca. Thanks for your input and comment on that. I almost forgot about the interoperability thing because it worked that well. But it's very important to mention. Yeah, I think that gets me to the next slide about the testing itself. So usually you start with a test client. So we had a specific test client that allows us to set any location just from the desk in the office. to check, okay, does the routing work? Do we get connected to the right PSAP? Then when we were sure everything works, we started with the live operation, which means Michael and I, we went to the Austrian-Italian border on Brennero and did some testing on either side. And finally, if time permits, we can also do kind of live demonstration. Starting with the test client, here you see that 3 different PSAPs in one web browser. So they all connecting to the backends. One is hosted in Italy and one is hosted in Austria in that case. And on the left side, you see just this kind of chat client that is command line based, but very handsome because it allowed us to set location. So I was sitting in the company, but the location you can see here, I think that's somewhere city center of Bolzano. So we use that for testing purposes and also to make sure that all the configuration worked. And after that, we went somehow live, and here are a few examples and screenshots of different types of integration. So from left to right, you see an integration with a CPE system in the PSAP. So there are some other means of communications here, and then there is the chat window in the middle, in the center. Below that, you see the iOS-based application with the chatting. So actually that belongs to the window behind, or the screenshot behind. And then the other examples are actually taken from the testing. Michael, I can't remember what we were writing. I think it was just test 1, 2, 3, 4, 5, whatever. But this is actually the border between Italy and Austria at Brennero. And you see here the location is north of the border, which means you're in Austria, and the other location is south of the border. And I think if you look into the details, you will find out that this person originates from Denmark. So this says DK. So we were using also the local deployment of the originating ESRP in Denmark. So the call flow was like starting the chat, connecting to the Danish ESRP, which then forwarded via the terminating ESRP in Austria to the right PSAP. And in between there was this lost hierarchy message flow. Yeah, and the other one is just an Austrian person moving to the south, and we got connected to the PSAP in Bolzano in that case. As Luca mentioned, we also did a real 112 call using the mobile network infrastructure, and being in Italy, but still connected to the Austrian mobile network operator, always connected us to the PSAP in Innsbruck. So dialing 112 was terminating at the PSAP in Innsbruck, but using the NG infrastructure, we were connected to the PSAP in Bolzano. A few more examples on the next slide. So this is the WebRTC example, and here you see Luca doing the testing. So on the left side, that's the mobile application, and on the right side, that's the PSAP application. Most important here, you also see the location. Calling from a specific location means that you get connected also to a specific PSAP. So actually the same things you've seen before, with the big difference that here it's a multimedia call. It's not just texting. A few more examples here with the detailed location information. So again, Luca is testing, and you see, I think in the middle, Luca, this is the location where we are calling from, and you see the place on the map in the PSAP, and yeah, there's a multimedia call which has video and audio included.
Yes, I just wanted to add a very small thing here, and it was, if you notice, the communication between the mobile phone and the PSAP is basically one-way video. Not because it was impossible to make a two-stream video call, but we wanted to represent a realistic case. I expect that in the future, if we are doing video calls, the PSAP operator, call taker, will not be showing his face to the citizen. So we wanted to show that even the existing real cases can be represented. This is not just a typical, okay, I make a video call. Video calls have been existing since 10 years or more, so that's not the scope. We didn't want to necessarily show that we can make a video call. We wanted to stick with the precise procedures and apply them to this new routing technology.
Okay, thanks. I think that actually concludes the technical part. Next would be the live demonstration. Just switching to another screen and asking Michael to start a call. So let's try. Perhaps I have to re-register. So what you see now on the screen, I hope you can see it, is the web UI of an Austrian PSAP. And I think if Michael starts a chat.
112?
112, yeah.
Yep.
It should, yes, it beeps in my ear. So now you can see where Michael lives. So could you just chat something, Michael? Yeah, hello participants. Hi, this is Wolfgang. So I'm sending it back to you, and then you see here the location of Michael and some additional information. Yeah, that's the still in operation. So the test environment that we rolled out for the testing. So thanks to RTR Austria for hosting that. And yeah, I think that concludes. And I'm jumping back to the presentation and hand over to Christina for the conclusion.
Thank you very much, Michael, Luca, and Wolfgang. I think it was a lot of work. Also, highlight the role of the PSAPs participating in this project, because what we wanted is really to go outside the plug test event that we already organized together with ETSI. We had already 3 editions, and we tested the interoperability between the components from different vendors, and this is something that was highlighted also. But this project also wanted to go a step further and work together with emergency services on this topic of NG112. So thank you really all to the participants. And here are some conclusions that this consortium focused the tests on the routing, the international routing, or the routing in through different regions. So that it's today it's a challenge for PSAPs, as we know, in the border of regions and countries. If the caller is really close to the border, the 112 call arrives to the wrong PSAP. So yeah, we tested successfully that the correct routing is done, even in the gray zones between countries and regions, and that the routing is done to the most appropriate PSAP. So this routing can also be extensible to other policies, so that it's not only the location, but it can be also the application that or the media content of the call. We can say really that countries can deploy Esinets now, so you don't have to wait. And we are also, we wanted to share with you the fact that we are working on a document that will be also an output of the whole project, that it's the NG112 implementation document, It's a high-level document with all stakeholders that have to work on the implementation of a national NG112 system, and we will publish them in the following weeks. So this is it for this first consortium of the project. We still have two consortia, that are the Croatian and the Turkish consortia, that will present their project and the use cases that they have tested on the 8th of June. You will receive the invitation. And I think now it's time for questions. So I saw already one question about if this call is recorded. So it is recorded, so I confirm it to you. You will receive all the materials after the webinar. And just please don't be shy. You can ask the question that you want. You can put it in a written way in the questions or on the chat, or you can raise your hand if you want to speak. So please do so. Okay, I see one question from Manuel Gonzalez saying, would WebRTC include in a future sign language simultaneously? I don't know from the three presenters who will be the best placed for responding.
Can I say something?
Yes, of course, Luca.
This is Luca. So yeah, let's say WebRTC, it's not an issue at all. The web client that we designed for the tests that you've seen in the slides before was actually making use of WebRTC for the client part. At some point in the chain, which I will skip, I mean, not to go too deep in the details, the WebRTC communications was transformed into SIP to allow the correct routing according to the Esinet principles. So this is not a problem at all. Also, the creation of so-called conferences with more participants to include an interpreter of sign language are possible. So it's not, let's say, this is like, we call it a border technology, or if you want, final technology that represents certain use cases rather than the core stuff, which will stick to the current standards for NG112. So yeah, this is not an issue.
This is Wolfgang speaking. Just let me add something. I think the great thing that we've shown with the project is that we have an infrastructure that is actually capable to route any type of call. Yeah? So if it's a multimedia call or just a text call, yeah? And I think it's just a matter of implementing it on the end device. Yeah? So being it WebRTC or another technology, as long as you utilize the interfaces towards an Esinet, you can get connected to a PSAP, and I think that's the great thing.
Okay, thank you. I see Victor Manuel said, thanks for solving my doubt. It is a very difficult labor because there are a lot of sign languages. I see a hand raised by Pascal Rotmack. I will unmute you, Pascal.
Hello, do you hear me?
Yes, we can hear you.
Yeah, thank you. Well, I have a question because here I see that in the use case you presented, the person calling the emergency services is using a specific application, correct? On his device, and
we hear you. We hear you a little bit far away. I don't know if you have, if you could be closer to the microphone.
Yes, is it better?
Yes, now it's better. Thank you.
Okay. So yes, I said that I noticed that unless I missed something, the person calling the emergency services in your use case is using a specific application. In this application, there is a SIP client, user agent, and this user agent is registering on a specific SIP proxy. And this SIP proxy is allowed to join this, well, have a trusted relation with the originating ESRP. Okay, that's the situation. Is it correct?
Yes, this is Wolfgang speaking. This is correct, yeah.
Okay, so now what I mean is that the situation we have is that most of the person will use the phone, and they will issue a phone communication using the providers, the telco. What about using the telco? What can we do from the voice company?
May I jump in, because it's also like, this is Michael speaking. So this is also a part of what Christina explained, that we're working on a document describing those scenarios. So just from a short point of view, for example, so you have already in the IMS voice over IP, right? So even if the call comes in to the mobile network providers, and as I stated before, they would obviously be trusted sources towards the Esinet.
Okay.
So they would forward then the calls via.
Okay, let's suppose that each providers on a given territory should be able to establish a trust relationship with an originating ESRP. Let's suppose there is a national Esinet, or maybe at least one, and then each phone company must establish a trusted relationship with entry points on the Esinet PCF.
So as they currently forward, I mean, it's depending on how the country is structured. So if you have like multiple telco providers handling emergency calls, if there's a specific one, but in the end they will. I mean, in the real the real goal is that you have a real voice over IP call starting from the phone. So in Austria, you already have the voice over LTA, those possibilities. That also means that you have native video and all those capabilities. So in the end, it will be that the phone providers which will hand over the phone call digitally via SIP towards the Esinet. Yeah.
And do you have any experience of such arrangement with a phone company able to route the emergency call to an Esinet in other countries?
I personally don't. Wolfgang or Luca?
Well,
I mean in Europe. I accept.
No, not yet. I don't think this is still the case. You're right. You mentioned, Pascal, not in Europe. I know in the US, several states have been doing it since many years. Even if, to be honest, it's always been a situation where they had a telephony exchange transforming the classical, if you want, GSM, PSTN, SS7, call it however you want, technology into SIP. So there was a sort of transformation at some point. No? Native SIP calls, including geolocation position as we used in our pilot, currently are not being transported yet by telecommunications operator. The closest thing I've seen to what you mentioned, Pascal, was last year at the flight test, where we had the possibility of native phones with voice over LTE, which were modified accordingly for the flight tests, able to send voice over IP calls on a BTS station, which was even modified to become next generation compliant. In other words, it was able to apply, for example, quality of service routing and stuff, and then forward it to the Esinet for call routing. So That was the closest example to what you mean that I've heard right now. 2 years ago, Romania issued a tender for the renovation of the NG112 platform, and in their tender, they included also the development of an Esinet solution, which brings me to consider that there was an agreement between the Romanian 112 entity, STS, and Telecom Romania to have them, I mean, the telecommunication providing SIP calls natively to the 112 Esinet. This is my guess, anyway, but
okay,
close to should be close to.
And you see, I'm not concerned with the fact that providers is able to issue a SIP call, because in fact today all providers interconnect themselves through voice over IP, through SIP, in fact. Okay, yep. All the interconnection is done like that. So, and Esinet should be no more, could be seen by any providers as another network, in fact. It's just towards route your emergency call, whoever you are, in fact. And that's all with the same technology as they are using for their own interconnection, their own peering, in fact. It's just a peering from the provider point of view. It's a SIP peering. The same
towards the Esinet, yeah.
Yeah, yes, exactly, yeah. So it's what is lacking now is that it's difficult to deal with the telco, with the also in the legislation, in the European legislation, and maybe I missed the name of excuse me. I think that in the European legislation regarding telco providers, they are obliged. No telco can counter the fact that another telco want to peer with him. Okay, peering is mandatory. The fact of refusing a peering is forbidden. I think this is in the European legislation, and I would like you. Anyone can confirm this? I read this in the Luxembourg equivalent of. I can remember the National Regulation Authority of Luxembourg state this very clearly just at the beginning, but it's not so clear in over legislation. If I could assert that, it would be very useful for me.
Just Pascal, if I may, we will go deeper into the from a legislative point of view and from a telco point of view, what is needed and what is the role to be played in the implementation of NG112 of the different stakeholders, precisely in this new document that we will share with you, with all the EENA community in a few weeks, and I think all the points that you have mentioned will be covered there.
Okay, this is very important, because if we really want to launch Esinet in the different countries,
I completely
because today everyone is using its phone. You take your phone, you take your device, and you compose the number. You don't ask anything else for the time being. So we must involve the telco invest, and we must clarify how they should deal with this when there is an Esinet. How should they route the message, the calls to this Esinet? It's not so difficult, and maybe yes, if the Esinet is just considered by the legislation as a specialized telco, in fact, providing specific service of public telecommunication, then they should peer with it just as they are peering with their colleagues, with their peers. It's just another peering, and it should be mandatory. Maybe, I presume it should be regarding the European legislation.
We take your point, Pascal. We have other questions, so as we take your points and we can share with you these documents, and
Okay.
we will be in contact.
Thank you, Christina.
Thank you, Pascal. And we have more questions here. We have one. Hi, does it only from Siegfried? Hi, does it only work with 112 calls, or does it also include national emergency numbers?
This is Wolfgang. I think that's easy to answer. For sure, it works with any national number, and you may have seen on the slides the example with the Austrian application. So here we in fact in Austria we have the situations where we have different numbers. We have the federal states, so it's quite a challenging environment. And the answer is yes, it works with any national number as well.
Okay, thank you, Wolfgang. Another one from Victor Manuel. How are you confronting the challenge in geographic zones with lack of proper cell coverage, like frontiers between countries?
I think that, Michael speaking again, I think that we had actually so in our test scenarios, we had actually the opposite. There was not a lack of coverage at the borders. The issue was that there was too much coverage, that the Austrian had coverage, broadcasted coverage into Italy and vice versa. So depending from which side you came, you had until, I think, Wolfgang, you had to walk like 2 kilometers inside the country in order to lose the coverage from the border country. So there was no issue with the coverage at all.
Okay, thank you. Then we have a comment from Bill Mertka about Verizon. And I think perhaps, Bill, what I can do is unmute you, and you can explain it to us, because I think it's very interesting what you have written here.
Yep. Can you hear me okay?
Yes, hello, Bill, we can hear you.
Yep. Yeah, I guess good afternoon to all of you. It's obviously still morning here, but yeah, I've been listening along quite intently all morning, and just you had somebody ask about carriers and delivery to ESINets and native SIP versus perhaps using converters, and I just wanted to embellish upon Luca's comments if I could, right? Since he was speculating about the situation, or at least commenting on what existed in the United States, I thought I'd provide a on the scenes, on the ground comment on that. And he's correct for carriers that have needed to connect to jurisdictions in the United States that have been deploying the ESINets for many years. That certainly is ongoing, and it has been happening for a long time. But it's been traditional, TDM-based delivery of connections to converters in ESINet, and next-gen core services like legacy network gateways and things of that nature to convert traditional LSS7-based traffic to SIP, and then send it on through the NGCS and ESINet. But somebody had asked about specifically carrier conversion and carrier delivery of native SIP. I mean, this is an active project that all of the wireless carriers, I think, in the United States are perhaps working on, but I know for a fact that we certainly are well along the path of making the modifications necessary on our side to start delivering calls, first for Verizon Wireless and eventually for all Verizon traffic as a native SIP to ESINet and GCS combinations that continue to sprout up around the United States. So I guess my message is if Verizon's doing it and working on it, then I'm sure our confreres here in the US are as well. I'm sure the leading telcos in Europe either know what they need to do, or certainly welcome to dialogue with Verizon and the other carriers here on how to make that happen. But I would suspect that within 12 to 18 months, major carriers, maybe a little longer, maybe not, that will start delivering native SIP calls to next-gen core services here. And as soon as carriers make the same technology changes on their end in Europe and other jurisdictions, it'll happen there too. So there's zero technology barriers. It's on the way, and it really is more dependent upon. Somebody made a comment about legal and regulatory, having those processes in place and having a what's the word I'm looking for, well thought out and well documented process for public safety entities requesting such things from carriers and then spelling out timetables for those to happen. That's really been part of the driver here, is that's gotten firmed up and cleared up through the U.S. Federal Communications Commission. The plans of carriers have become a little clearer and the technology paths have become a little surer based upon those processes. So there's no technology barriers to that. It's coming. I think, like I said, in probably 18 to 24 months, you'll start seeing such things start happening here. And just thought I'd provide that perspective since somebody asked.
Thank you, Bill, for sharing this. Okay, so let's move to the next question from Martin. We have similar projects in Czechia, Austria, Slovakia, and Hungary. Localization, chat, and video. We are interested in for us to integrate with similar platform. Do you have some technical documentation of your solution? So I don't know if
quite easy to answer. I mean, we also said that we will keep running the pilot, so whoever wants to integrate should contact you, Christina. And basically, from a technical specification, it is exactly the standard document which is referenced on the slide. So there are no proprietary interfaces. It's just the standard interfaces.
Okay, thank you. Then we have another question from Axel. General question. And hearing about your NG112 test results was quite interesting. What is the timeline you see until next generation eCall needs to be strongly considered? When will NG112 become interesting for automotive world? So
we have discussed this recently, Christine.
Yes.
Let's say that next generation eCall as a standard protocol is already existing. You can find documents on the, Christina can probably even send you the links to the proper documents to at least get to know about this technology. About the deployment of NG eCall, I hope that it will be concurrent, simultaneous with the first deployments of full IP networks. Remember, you can install an Esinet anytime, let's say, even now. No? Bill explained very well that the US have been deploying Esinets since many years, and they didn't need to wait until the telcos switched off all the 3G or 2G networks. No? So the implementation can be done even now. We are living in a migration phase from all the 2G, 3G technologies and PSTN in general to the full IP technology, which will benefit 100% of these Esinets. So next generation eCall, in some extent, sees as a deadline the implementation of those networks, because it will also exploit 100% the capabilities given by full IP services. Just to make it very simple, but I don't want to go in deep into technology. Imagine when eCalls MSD could be transported inside the SIP invite of the call, just like an XML file as they are supposed to be. But for doing that, you will need a network that supports voice over IP eCalls, extended payload into the SIP invite, and so on and so on. So these are really network-related elements, more than Esinet can support it even now. You can inject a next-generation eCall example, and trust me, Esinet will be able to manage it. It's what's before that has to be dealt with.
Maybe I add something, Wolfgang?
Yeah, go on, Michael.
What is, I think the NGE call with also can benefit from the additional routing capabilities. So, like when you have not all PSAPs will be able to handle the NGE call at one point in time. So also with the Esinet, you can do use the powerful routing capabilities to, let's say, okay, all NGE calls go to the first PSAP independent of the location, because maybe the others are not ready yet, and you can have all those possibilities within the NG112 architecture as well.
Okay, thank you.
This is Wolfgang. Just one comment regarding the question when it becomes interesting for NGE call. I think the answer is now. We need to make sure that things converge, and not. It should not be at the end that things are diverting. Yeah. So there's one NGE call deployments and there are Esinet deployments. I think at the end it should work together. And as Luca said, that the Esinet can forward such information, so that's really not an issue.
Okay, thank you. And well, this is what we are currently also working on, to make sure that the next generation eCall is not diverting from next generation 112. This is something that we are looking at very closely. So I don't see any other questions. So last chance to all of you to ask a question to our presenters. I don't see any raised hands. So I think we can now close the webinar. Thank you very much to the presenters, to all the organizations that have participated in this consortium. Of course, all the participants that you came and listened to this webinar. And as said, we will have on the 8th of June another webinar on the NG112 project, that it will be also very interesting what it was tested in Turkey and Croatia. And in the meantime, we will publish the report of the Turkish consortium at the end of this week. And beginning of next week, we will publish the report of the Croatian consortium. So nothing more on my side. Thank you again, and have a good end of the afternoon. Bye.
Thank you. Bye.
Bye-bye.
Bye.